Hi, this is Jeff from Parking Alert Signs. I'm introducing our PSC6 Traffic Control System. I've set up here in our shipping department on a single table so you can see how everything works at once. Applications. Applications for the PSC6 is used in simple two-way intersections, four-way crossovers, or up to complicated multiple-way traffic control intersections. It can be used in tight ramp turns, stopping traffic from entering corkscrew ramps, and in controlling traffic in truck yards. You can also use the PSC6 with a combination of our warning signs to push visual and audio messaging. You can even integrate pedestrian traffic control into the system to stop traffic while giving signals to pedestrians to cross safely. The PSC6 is not intended to be used in street speed traffic applications. It is intended for traffic that is typically 15 miles per hour or less. Components. Components are broken down into three sections. Group 1 is the controller itself. The PSC6 control board is the brains of the operation and allows a multitude of programming options. Group 2 is input detection. Detecting vehicles and pedestrians can use a multitude of devices, including vehicle motion detectors, as shown here on the table. You can also use vehicle loop detectors and outputs from roll-up doors and gates, even pedestrian push buttons. Here I'm using a vehicle motion detector that only detects vehicles approaching the detector, not vehicles moving away. This prevents false detections in cross-traffic intersections. Let me demonstrate. As I approach it, it detects it. If I come up to the motion and reverse, it does not detect it, but as soon as I go back towards it, it detects it. This minimizes those false alarms on cross-traffic intersections. Group 3, control output devices. This is what gives the visual and or audio indicators for traffic. Here we're using the red-green 10x6 traffic light. But you can also use signs or even audio devices to alert vehicles and pedestrians. Don't stress about the design. We can help you with everything, and we have many engineered systems ready to go. Operations. Let's see our setup here in action. I have set up vehicle motion detectors to activate from my hand, simulating detection of a vehicle. Let's picture this setup as a four-way intersection. We have our north lane, east, south, and west lane. Red operations is designed when you want to stop traffic before an intersection and then provide a green light when the traffic is clear. Here I'm going to simulate a vehicle is detected. I have the activation timer set for 5 seconds so that after 5 seconds, the system will return to normal. Typically, you would use 8 to 10 seconds, but it's all adjustable in programming. So what happens if we have two cars? I have a car here, and then I have a car that's detected here. When I simulate a car from sensor 3, and then immediately from sensor 2, and then from sensor 4, you can see that the detected vehicles are queued into the system. Now just imagine if I had this set up for 15 seconds apiece, it would be a very long video. So you can see 5 seconds, 5 seconds, 5 seconds. However, let's do this where a vehicle is detected on sensor 3, and then another car right after the first vehicle. This starts the activation timer over. This is designed to avoid a secondary green light to activate when a vehicle is still in the intersection. So I activate here, I activate the second one, I activate this. This will continue to allow the operations to stay on this light, and then eventually when traffic is clear from this lane, it will go to the second lane. The green operations is typically used for warning systems on ramps or in truck yards to keep slow-moving traffic flowing unless there's really a reason to stop it. The system works very much like the red operations. As you can see, all lights are green. When a vehicle is detected, all other lights go red. There's one more mode, but it follows all green operations. As you can see, there's no lights here on at all. However, this is if you're using red lights only. So sometimes you don't want the green lights because you might feel that, hey, traffic's going to speed through your facility if they see a green light. All right, so as they approach an intersection, it's going to detect them and turn on red lights in every other direction. And it works just like green lights and red light operations, but there is no green lights. Okay, let's take a closer look at components. Now, I'm freehanding the camera here so you guys can get up close and personal to the control board. So the first thing that we have is our power supply. It's bringing in AC voltage, typically 120 volts, but it can go all the way up to 240 volts. And it's transforming that down to 12 volts DC. We have a power switch here, and we have our 4 test buttons. Now, right now we have this in all green. So what I'm going to do is go into programming and just show you how easy it is to program. I want to change this from the all greens mode to all reds mode. And I'm just going to press enter and next. And it's going to let me go into programming. And I'm going to use the next button to get up to P015. I'm going to hit enter. And I'm going to change this to 0, which makes it all reds mode. Here's enter. And then to escape or exit programming, I'm just going to push the reset button. And now our lights are going to go from all greens to all reds. Okay, ready to go. So programming interface, very simple. Reset button, input, trigger, test buttons. Next is our outputs. We have 8 outputs. Obviously, if we have 4 traffic lights, there's 2 outputs per traffic light. So 1 and 2 are for traffic light 1, 3 and 4, traffic light 2, 5 and 6 for 3, and 7 and 8 for traffic light number 4. As you can see here, I've wired up, I just use an 18 gauge 4 conductor to the traffic light. I use red and black for my reds, and green and white for my green light. And back here on the actual device, you can see right inside there, same thing. Red, black, green, white. Very simple, straightforward to manage. Each output is 12 volts DC and can power up to 1 amp. Now, if you're using a 5 amp power supply like this one here, obviously you're not going to get 1 amp on every single output. So remember that. But this is why it's important to buy our engineered kits. They're ready to go. They've already been tested. And they're easy to install for your electrician. Next we have, I want to continue on with the outputs. So we have here 4 traffic lights, and as we activate them, we can see that they are constantly on. There's no flashing involved. So I'm going to change that. I'm going to allow some of these to flash and some of them to be constantly on. All right, so how I'm going to do that is I want to flash green, and I want this one to flash green, and I want this one to be a flashing red and this one to be a flashing red, just to mix it up a little bit. So I'm going to go into programming. I'm only going to show you the first one here. I just happen to know that that's going to be output number 2, which is at P008. And I'm going to hit enter. And right now that says constant. I'm going to change that to flashing, and I'm going to hit enter. And let's just test that real quick. So red is on, and now I trigger this unit, and now the green flashes. So I've paused the video and made some changes here. As you can see, these two flash red, but the green is on constant. However, over here we have constant reds, but greens are flashing. So each output is programmable if you want it to flash or be a constant. Inputs. So there's 4 trigger inputs located on the board. Input 1, 2, 3, and 4. The power for your sensors, such as these motion detectors here, can come directly from the board itself. You don't have to put it in an extra power supply. This will output 12 volts DC for power for your sensors. Okay, so one of the things is say you have a corkscrew ramp and you're detecting vehicles coming down from the second or third floor, and the second floor obviously takes a little bit more time to come down than say the first floor. All right, so right now we have 5 seconds on that floor and 5 seconds on this floor. But I need 10 seconds to come down from the second floor. So I'm going to go into my programming here. And I'm going to go to P002, which is the activation timer for input number 2. And I'm going to hit enter. And I'm just going to change that to 10 seconds. And then I'm going to hit my exit button or reset button. And what that does is when it comes back, that's for 5 seconds. And this one here will be for 10 seconds. Now each input can be triggered by a normally open or normally closed connection. So you can decide if you want to find out if your device is normally open and normally closed. Normally open is very typical. It's the most common output from motion detectors. So let your electrician worry about that or give us a call to find out. That's it. If you need help with design or have questions, let us know. We are here to help you meet your goals of a safer facility.